Alright, welcome back. So, we're going to start Chapter 7, Section 3 today. And we've been talking in the first couple sections of this chapter about exponential functions. We talked about how to graph them, what they look like, and we've messed around with them a little bit and solved some equations and inequalities with exponential functions. The simplest form of an exponential function, something like y equals b to the x power, again, having that x in the exponent is what gives us an exponential function. So, now that we know a lot about those, let's see if we can find the inverse function of this exponential function. So, if we follow our steps, the first step was to change f of x into y, but we've already got y here, so we're good. If we want to find the inverse function, that's where we flip x and y. So we change the y to an x, and we change the x to a y, so this is now x equals b to the y power. Okay, so we flip x and y. The next step to finding the inverse function would be to solve for y, to get that y by itself. So, how can we get the y by itself here? It's in the exponent. Some people might think dividing by y on both sides, that's not going to get rid of that y. So, if you've got something like, if you've got something like this, x to the third power equals 27, how do you get the x by itself? Remember? We need to take the root of both sides, and the index of the root has to match the exponent. So we would actually take the third root, or the cube root of both sides, to get that x by itself. So if this is to the y power, technically we should be taking the yth root of both sides. But if we do that, we get rid of the y on this side because the yth root and the exponent of y cancel out. But now we've got the yth root of x, that y. It is still not by itself, and you could argue this is an even bigger problem than what we started with in terms of getting that y alone. So, I'm just going to erase all that because it didn't work. We're trying to find the inverse here. We're trying to get the y by itself. You can't. You can't get the y by itself there. At least, not without making something up. So, a long time ago, some people, they knew about these exponential functions, and they're like, well, if it's a function, it should have an inverse. And they tried doing this, and it didn't work out. So what they ended up doing was creating something new. And so to get the y by itself, what they did was write this. And it looks really strange. It's hard to see how this and this are equivalent. But let's talk about this for a second. This log here is not like part of a tree that's been cut down. It's not that. Okay? This is what's called a logarithm. A logarithm. Okay? But we will always refer to it in terms of a mathematical expression or equation. When we're writing in math language, we're only going to write it as log. Okay, that's much shorter than logarithm, so mathematicians like that better. We don't like letters very much. Disregard the fact that this is all just letters. We don't like words, so we shorten it where we can. So this is a logarithm, and what this is saying is, if you take this value, b for the base, right? B to this power will give you this. These two equations are equivalent in what they're trying to say. They're just saying the same thing in different ways. So, this gets to the point that there are two different ways to write the same thing, and we actually give each of those things names, forms, okay? This type of function is what's called exponential form, right? Because it's got an exponent in it. So something in exponential form looks something like, it's going to be this, but I'm actually going to flip this around, or b to the y equals x. Okay. Something in exponential form is written this way. You have a base, which in this example is b, but normally it'll be a number of some kind, like 3. And then you've got your exponents. So you've got base to the exponent power, so in this case that would be y, is equal to, we'll just call that the answer. Base to the exponent power equals answer. That's what we have right here. That is an exponential form because it's got an exponent in it, in an exponent's place. Okay. So, we want this to be its own form. So since it has a logarithm in it, we're going to call this logarithmic form. Logarithmic. Logarithm is a noun. This is a logarithm. Logarithmic is the adjective. This equation is logarithmic. It is in logarithmic form. Okay? So, the way this one would be written, I'm going to use my blue here. Okay. And again, we could switch these two sides around. Log base b of x equals y. Okay. These mean the same thing. This and this. So we could have log. Now the base is down here. Okay. This is referred to as the base of the logarithm. So it's still a base like it is up here, but now it's the base of this logarithm, this log. The x, remember, we refer to as our answer. So it's going to be log base answer equals the y. When it was in this form, we called it the exponent. Now the exponent is what's over here. Okay. So we've got the same three things going on in both of these forms. We've got a base, we've got an answer, and we've got an exponent. Okay. So you can even write arrows here if you're going from one form to the other, which we're going to be doing a lot in this section in particular. We're going to want to write something that's in exponential form, be able to put it in logarithmic form. If something's in logarithmic form, we want to be able to put it in exponential form. We should be able to go both ways, speak both of these languages. Okay. This might still feel a little overwhelming. A lot of what's left in this chapter, we're going to be dealing with how we can do math with these logs once we've introduced them. But for now, in this section, we're just talking about how to get from one form to the other, and maybe a little bit about what these logarithmic functions look like. But for now, we're just going from one form to the other. Let's start with this example right here. We've got example 1a in our notes. It wants us to write this equation in exponential form. Okay. So as you can see here, this has a log in it. So this is currently written in logarithmic form. And we want to write it in exponential form. So, for some of you, you might already know exactly what to do to write that in exponential form. If so, fantastic. If not, here's what I would suggest doing. Okay? Problems like this, you're going to need a base, an answer, and an exponent. So what I might do here is write out what each of those things is. So base equals, I'm going to write that with a lowercase b. Base equals, answer equals, exponent equals. Okay, I'm just going to fill in which number is which. If we know this is written in logarithmic form, the base should be the number with the log, which is 3. The answer is the number right next to it, that's 9. And the exponent is what's after the equal sign. In this example, that is a 2. So we know what these three things are. We should be able to write that now in this form, in exponential form. We just need to write it as base to the exponent power equals answer. The base is 3. The exponent is 2, so we're going to write that as the exponent. So it's 3 to the second power. And that equals, answer is 9. 3 squared equals 9. So not only have we now written this in exponential form, but what we've written should be something that is true. Is 3 to the second power equal to 9? Yeah, 3 times 3 is 9. So if you're going from logarithmic form to exponential form, you should be able to check your answer and make sure that it makes sense. If you had flipped these two numbers and written 2 to the third power equals 9, you could check this and make sure, is 2 to the third power 9? 2 times 2 times 2? That's 4 times 2, which is 8. So by checking your answer, you'd be able to see something was wrong here, and you'd be able to fix it. And as you do more examples like this, you might not even need to write this off to the side. If you don't have to, you don't need to. But if you're just getting started, if you're uncomfortable, if this log stuff is really just throwing you for a loop, what I would recommend is definitely having this on paper somewhere, whether it's on your notes, whether it's on a separate sheet of paper, whether it's on your arm, whatever, okay? But going from one form to the other, have this and write them out. Write out what each one's equal to. That way it should be easy enough to plug in what you need here. So, we've got 3 more examples here. The notes actually have a lot more examples. We're only going to do the next 3 in this video. We'll do the rest of the front page and actually start the back page in video part 2. So, all we need to do is these 3. These are all similar to this one here. So, whether you're comfortable yet or not with these types of problems, what I'd like you to do is try out these 3. Okay? You've got everything you need. So on your paper, try out these 3 examples, pause the video for a sec, and when you come back, we'll see if you got them right. Alright, I know you just paused that video. It's been at least like a minute since we did that. Okay? If you didn't pause the video, I know. You should pause it. Pause it now, this is your last chance. Okay. So, we want to write this in exponential form. So again, we're starting in logarithmic form. So we should be able to find our base, answer, and exponent. The base is this tiny number here, 10. The answer is the number right next to it. That's going to be 1 over 100 here. Don't freak out about the fact that it's a fraction. That's perfectly okay. It's still just this number here. And the exponent is the number after the equal sign, -2. So if we want to write that in exponential form, we need to write it like this. Base first is 10. The exponent is -2. And that equals the answer, 1 over 100. Maybe that's what you got. If so, great. If not, well, maybe you don't trust this. we can check this. All we need to do is determine that 10 to the negative second power is 1 over 100. Well, 10 to the negative second power, if we've got a negative exponent there, we could write it this way, 1 over 10 squared, which is 1 over, this is 10 times 10, which is 100. So yes, 10 to the negative second power is 1 over 100. That has been done correctly. Maybe if you were lost after the first example, seeing both of these together has made you a little more comfortable. If you haven't paused the video yet to try these two, give that a shot real quick. We want to write this in exponential form. I'm starting to get a little lazy in terms of what I write down. Don't get lazy. Don't be like me. I'm old and I've been doing this forever. Okay? If you still want to write out base, answer, exponent, perfect. So we've got a base of 2 here. The answer is going to be the 8, and our exponent is 3. Okay. So in exponential form, we've got our base to the exponent power equals the answer. 2 to the third power equals 8. Yes, and we proved that when we said that you could have done this incorrectly. 2 to the third power is 8. One more here. Got log base 3 of 1/9 equals negative 2 in exponential form. After you do a few of these problems, going from logarithmic form to exponential form, you might start noticing patterns. You don't even have to write necessarily what everything is. You might just notice where things go. This number goes here. This number goes here. This number goes here. Here, here, here. As long as you're going from logarithmic form to exponential form, that should still happen. Three to the negative second power equals 1 over 9. Now, if that was not clear, you don't have to do it like this. Okay? Go ahead, write out everything off to the side, make sure you get it right. But if you're someone that notices these patterns over time, where things go, that'll make it faster. Okay? I'm not interested in how fast you can do it necessarily. It's just some people like looking for patterns like this. Math is full of patterns. Okay? So, I think that's good for now. Again, in our next video, what we're going to do is we're going to go the other way. You'll be given something in exponential form and have to write it in logarithmic form. And you'll find that you do the same thing. You can write out what each of these 3 things is, and as long as you've got these, you can tell where they go. We'll also start talking about evaluating logarithmic expressions in the next video. So what do these things equal? What does it mean to take the log of a number with some base? We'll find that out next time. So, I hope you're waiting patiently for the next video. Maybe it's already on Canvas, you can take a look already. Who knows? But we will see you next time, and until then, have a great day.